Okay, if none, then let's start. Again, good afternoon, everyone. So this would be our third meeting for Math 155. So for today, we'll try to finish the order axioms, which was supposedly covered last week. But since we devoted the first meeting for simply an orientation for the class, then medyo delayed tayo ng one meeting. But that's fine. We can adjust later. So we'll try to tackle the order axioms and then go to completeness of the set of real numbers. And if time allows, let's consider some consequences of the completeness axiom and talk about some topology on the set of real numbers. Okay. But just some housekeeping notes. Again, the deadline for homework one was moved to Friday the 24th. So burahin ko na yan. I already adjusted the deadline in Canvas. And then remember last time we saw some minor typo errors on the lecture notes. So what I did was to correct them on the source file and re-upload it on my Google Drive, which is linked to the Canvas website. So if you want to get updated copies of the lecture notes, then you can just regularly visit the link in Canvas, and you'll get the updated typos. I mean, after I corrected all those minor typos. Okay, and then I noticed last time that I made probably some errors in my proof for Theorem 1.4. Those nabanggit ko lang siguro na nabanggit ko lang pero the idea is still the same. So in particular, this is in the proof of root 2 being irrational. Hold on. By the way, guys, nakashare pa ba yung screen ko or nag-stuck na rin? Let me just restart kasi hindi ko na siya nakikita. So ito, nag-adjust pa rin tayo sa internet connection. But hopefully you're hearing me well. Okay, yun na uli yung screen ko. Hopefully, come on. All right, so there you go. So I guess towards the end of the proof, dun sa malapit na sa contradiction, I need to correct these kasi I think when I discussed it last time, when we had 4p squared equals m star squared equals 2n squared, and then I said we divide both sides by 2, then I concluded right away that n star is even. I guess there is a mistake here. It should have been, meron pa dapat tong square. Tama ba? Yeah. Because I simply divided both sides of this equation by 2. So we should get 2p squared equals n star squared. Okay. And then the fact that we have shown earlier that if you have a squared number that is even, then automatically the number inside the square should also be even, right? So if m star squared is even, then necessarily m star is also even. And that's the case that we have here. We have n star squared being even, being equal to 2p squared, where p is some integer, right? So that means n star squared is even, and consequently, n star is also even. So, and then the contradiction follows. I guess last time when I divided both sides by 2, I already said that n star is even. There is a typo. I already corrected it in the file in the online file, so you can re-download it so you can get the corrected copy. But anyway, now I think everything is in order. Okay. So we now can move on to the order axioms, the next section for the class. So here we will just formalize the natural ordering that we had been using for the set of real numbers. Specifically, this is the less than or the greater, the less than or the greater than relation. But again, we are rebuilding the set of real numbers together with all the properties that we have learned before. And so para ma-bootstrap natin yung construction ng set of all real numbers, we are defining everything again from scratch. And that includes the ordering of the set of the set of real numbers. Okay. Now, in that ordering, we have some concept of the set of positive numbers. Remember, when we created the set of real numbers, we don't have any notion of positive or negative numbers. Remember that the symbol negative a is actually not negative a, but this is the additive inverse of the real number a. And so wala pa talaga tayong strict notion what is a positive and what is a negative number. And that will only come after we stated axioms 10 and 11. Okay, so it says here that there is a subset curly P of the set of real numbers, and that's what we will call the set of positive numbers. And that set in relation to the set of real numbers is governed by two axioms, and those are axioms 10 and 11. Axiom 10 is what we call the trichotomy axiom. So it says that for any real number a, exactly one of the following three scenarios hold. Either a is equal to 0, or a is positive, or a belongs to the set of positive numbers, or it is the additive inverse of a that belongs to the set of positive numbers. So in trichotomy, as the name implies, trichotomy, we divide it into three. So ibig sabihin, any real number will fall under or exactly under one of the three categories. Either a is 0, which is the additive identity, a is positive, or the additive inverse of a is positive. So ito yung notion natin ng positive. Pero so far, wala pa tayong dinidefine kailan siya nagiging positive. Because this axiom is just putting the set of all real numbers under three classes. Okay. Now let's introduce axiom 11, which will characterize the set of positive real numbers. So it says here that if a is a positive number, because a is an element of P, and b is also a positive number, then a plus b should be positive, and a times b is necessarily positive. So you can think of axiom 11 to be the characterizing property or the distinguishing property of the set of positive numbers. Okay, so we know that a number is either 0, positive, or its additive inverse is positive. And then to determine, or if you have two numbers that are known to be positive, then their sum and their product must both be positive numbers as well. And then, para mabigyan natin a notion what does being a negative number means, we define it here. A number a is said to be negative if its additive inverse is positive. So from now on, hindi na intuitive yung paggamit ko ng positive and negative real numbers. So I can say now that the notion of being positive and negative have their actual meaning in our construction of the set of real numbers. Okay. Now, we formally define in definition 1.2 what being less than means. So we say here that a is less than b, written this way. A is less than b if and only if b minus a is positive. Okay, or more technically, b minus a belongs to the set of positive real numbers. And similarly, we define yung usual notion natin. A is less than or equal to b if and only if b minus a is a positive number or a is equal to b. A is greater than b if a minus b is positive. And a is greater than or equal to b if and only if a minus b is positive or a equals b. So whenever you want to prove something about the less than and greater than relations, then we always go back to definition 1.2. Kasi ito yung panghahawakan natin as the very definition of being less than or greater than. All right? I think isa sa mga mahirap na bagay with 155. We need to let go of those notions that we know before, kahit napaka-obvious nila sa atin, pero ngayon binibigyan natin sila ng technical and mathematical meaning. So, okay. All right, so remark 1.4 is just a play on these symbols. It follows that a is less than b if and only if b is greater than a. And similarly, a is less than or equal to b if and only if b is greater than or equal to a. So if you want to prove remark 1.4, so we just apply definition 1.2. And I guess you can try this kasi parang 1 or 2 liners lang yung proof. But be careful, we are doing things formally. So, kailangan susundin natin yung mga definition na yan. Okay? Now, major result, we have Theorem 1.5. It says here that if A, B, and C are real numbers, then we have 8 properties here. Perhaps we can prove some of them just to illustrate how definition 1.2 can be used. All right? So ano kaya yung okay na i-prove? Let's see. Let me do the first one while you browse through the other 7. And then after we prove number 1, you can suggest to me which one you want to prove here in class. Okay. So I'll try the proof of 1. Okay. So the assumption here is A is less than B and B is less than C. And we want to show that A is less than C. So basically, this is the transitive property for the less than relation. Okay. Alam na natin to since elementary, but now we will write a formal proof using the axioms and the definitions that we have given so far in class. So one way, or this is actually how I do my proofs, I first list down what are the things that I can get from the given information. So here, our assumptions or our premises are the following. A is less than B and B less than C. So these are the premises. They're assumed to be true. And then I'll try to write what they mean. At least what is the immediate meaning of these assumptions? Well, luckily for us, we only know a few things so far. So that means wala akong masyadong pwedeng gamitan, but only the definition of the less than relation, right? So remember that A is less than B, A less than B means B minus A is a positive number, correct? And then B is less than C, that means C minus B is a positive number, right? Coming from the definition of the less than relation, okay? And then I always put on the side what I want to show or what's my end goal, because I need to manipulate the assumptions, use logical arguments or logical implications coming off from them in order to come up with the conclusion. So para mag-guide ako kung ano yung goal ko lagi, I always write what I want to produce after doing all these logical arguments. So here, I want to show that A is less than C. But I can do that by showing, because this is equivalent to C minus A being a positive number. And then I compare what I have right now. So I have this guys, and then I have this guys, plus certain axioms before, right? So gusto ko magkaroon ng C minus A in the first place, and I want to show that C minus A is positive. But from the things that I have so far right now, how can I get C minus A? Well, you look at this column. I can get a C minus A if I will what? Any idea? I hope you get the process. I'm looking for a way to get a C minus A out of my arguments, right? The arguments or the premises that I have so far right now is that B minus A is positive and C minus B is positive. Now, how can I get a C minus A? Anyone?
By adding them po, sir.
Okay, thank you, Dan. Yes, I can simply add B minus A and C minus B. And there I'm going to get C minus A. And I'm halfway done because I have C minus A, or I can have it appear in the middle of my arguments, right? But I want to also conclude that C minus A is a positive number. And how can I do that? What's the result that will tell me that C minus A is a positive number? Anyone else aside from Dan? Paano ko mako-conclude na si C minus A positive number? And we can leave from what Dan earlier suggested na makukuha natin yung C minus A by simply adding these two guys. But how can I say that C minus A is a positive number? Because if I'll be able to get that, then we're done. Yes, I heard someone.
Yung definition po kanina na may pag may pinag-add po ay positive pa din siya.
Okay, thank you, Neil. Oh, yeah, that's perfect. we have seen in Axiom, what number is that? Axiom 11. Kung meron kang dalawang positive numbers, tapos pag in-add mo daw sila, automatically positive pa rin yung makukuha natin. And that's exactly what we did to get C minus A. We added B minus A and C minus B, which are both positive. And I guess that's the outline of the proof. And now what's left to be done is to write it in details. Maybe I can add another page here para makita nyo rin paano natin i-formalize yung idea natin, because it's not sufficient to write an analysis or a computational doodles on the side. Kailangan din nating isulat siya formally. Okay. So maybe we can do that here. So here we are proving. So here we want to show that if A is less than B and B is less than C, then A is less than C. Then we can write the proof this way. So from the premises, we can say that B minus A is a positive number and C minus B is another positive number, right? These are exactly the definition of the less than relation used in the premise. Okay. Then B minus A, then as Dan suggested, I'm gonna add them up, plus C minus B, all right? And then what can I do now? Well, I can write it as negative A plus B plus negative B plus C by commutativity of addition. I forgot what the axiom number is, pero kung alam niyo yung title o yung keywords, then that's perfectly fine. Then I can write it as negative A plus B plus negative B plus C by associativity of addition. And then this will become negative A plus C by property of additive inverses. Okay. And then final step probably is by commutativity again. And so, all right, then C minus A is a positive number by axiom 11, if you remember the axiom number. But actually, I prefer if you will describe the axiom instead of putting the number, para rin kung may magbabasa ng proof nyo who is not member of the class, then he or she will know na ito yung property na ginamit natin. But for me, it's fine if you write A11 because you have the notes beside you when you're doing your homeworks or your problem sets. But probably, if you want, you can say C minus A is in P, being the sum of two elements of P. Okay. So I can say C minus A is in the set of positive real numbers because it is the sum of two elements of the set of positive numbers, which is basically what is being implied by axiom 11. Okay. So C minus A actually is the same as A being less than C. And that ends the proof. All right. Any questions? Probably it would be, you might, actually you may skip some of the parts here. I won't be looking for some obvious steps like, baka sabihin niya, sir, alam ko na to kagad, B minus A plus C minus B. Sir, alam ko na yan ay C minus A kagad. Well, okay, I will accept that if you start here and end up here, okay? Kung kalimutan niyo na minsan yung mga minor reasons dito, then that's fine. But I would love to see that you write A11 or arguing that C minus A is positive because it is the sum of two elements of the set of positive numbers, because that's the that's the gist, or that's the meat of the proof. So I want to see it written on paper. Okay. Pero in my proofs in the class, I will show all the details. Tapos paunti-unti ko na lang silang babawasan as we go along. Because I just don't want to teach you Math 155 content, but also how to write a proof and how to reason out logically. Okay? Any questions? Ito pala, I won't be uploading my doodles in Canvas. So if you want, you can take a screenshot of this proof, or better, if you're taking down notes. Okay, questions. Madali ba yung proof? Or pinahirapan ko pa siya pero mukhang simple lang talaga siya. But here, I want to include all details and show you how all the axioms that we have defined before played a role in this particular proof. Okay, no questions? Okay, kung ayaw nyo magsalita, you can use the reaction buttons. So just a thumbs up, so that would be fine. Just for me to know na, okay, nakakasunod kayo, you have no questions, at para malaman ko na online pa rin ako. Baka pala nagmo-monologue na ako and I'm not online anymore. Okay, so if there are no questions with that, let's prove another one from here. Do you have any suggestion? Wala kayong suggestion? So ako na yung pipili kung wala kayong suggestion. Oh, let's try to prove, say, property 6. So here we are saying that 0 is less than 1 and -1 is less than 0. These are two things that we were taught way back in elementary, right? Pero bakit nga ba tayo pumayag na ang 0 ay less than 1? Simula nung elementary tayo, pumayag tayo na totoo yan. Pero bakit nga ba? Hindi natin hinanapan yung teacher natin ng proof kung bakit ang 0 ay less than 1. And probably mapapagalitan kayo pag humingi kayo ng proof for that. Kasi you have to wait until now in Math 155 for us to prove that indeed 0 is less than 1. Okay? So it might be interesting to look at the proof of that statement. So let's try to put that here. So we want to prove that 0 is less than 1. Ano kaya yung pwede kong gamitin? Okay. So perhaps let's do a preliminary analysis. Dito na lang siguro sa gilid. Okay. So I want to show that 0 is less than 1. I don't have any assumptions yet. But here I want to show that 1 minus 0 is positive. But 1 minus 0 is just equal to 1. So basically, the statement that 0 is less than 1 is tantamount to the statement that 1 is a positive real number. Kasi wala pa tayong kilalang specific real numbers na nandun sa set of positive numbers, right? So ang alam lang natin yung mga properties ng set na yon. But we don't know specific members of that family or that set. So this might be a good start. Let's prove that 1 is indeed a positive number. Actually, dito wala pa ako na-violate. First principles pa rin yung ginagamit ko kasi yung 1 minus 0, baka sabihin nyo, nag-shortcut ako or dinamit ko yung natutunan natin before. But remember that 1 minus 0 is the same as 1 plus -0, right? Pero ang additive inverse ni 0 ay sarili niya because 0 plus 0 equals 0. So ibig sabihin ang additive inverse ni 0 ay sarili niya. So that means -0 is just 0. So this would be 1 plus 0. And then 0, being the additive identity, doesn't add anything to any other real number. So 1 plus 0 is equal to 1. Okay. And then this is what we want to show, that indeed 1 is a positive number. All right. So any suggestion how? Ito yung mga mahirap i-prove, yung mga bagay na pinapaniwalaan na natin before, na hindi natin hinanapan ng proof before because they are very obvious, but now we are required to prove them. Now, one way to prove this probably is via contradiction. So here I will assume that, okay, maybe I should write that down, proof. So here I want to show that 1 minus 0, again, I have mentioned that this is equal to 1, is positive, right? So ito na yung assumption natin earlier, right? Perhaps I will mention here na note that 1 is not equal to 0, okay? So, ibig sabihin, isa na lang yung natitirang case. Actually, dalawa. 1 is in P or negative 1 is in P. If we will be able to show that negative 1 cannot be in the set of positive real numbers, then by the trichotomy axiom, we are left with no choice but to accept that 1 is a positive number. Okay? Probably I can do that. I can bank on that strategy and do a proof by contradiction. So now I will suppose, for the sake of contradiction, so again, I'm using a $sign para i-denote yung supposition for the sake of a proof by contradiction. Kaya usually binabasa ko to as suppose for sake of contradiction that negative 1 is in P. Okay? So kunwari siya ay positive number. Then, what can we say about negative 1 times negative 1? Anyone? Makita nyo mamaya bakit ko gustong paglaruan yung negative 1 times negative 1. Pero anong pwede nating masabi using the principles or the things that we already proved or defined earlier about negative 1 times negative 1? Assuming that negative 1 is positive.
Na positive pa rin po siya, sir.
Okay, thank you, Neil. Yeah, that's correct. Since we are assuming that negative 1 is positive, remember axiom 11? Pag meron ka daw dalawang positive numbers, minultiply mo sila sa isa't isa, we get another positive number. Since here I am assuming that negative 1 is positive, yan, ibig sabihin yung negative 1 times negative 1 should be positive, right? So being the product of two elements of P. All right? Now, let's try to get a contradiction from that, okay? Ano kaya yung pwedeng contradiction? Now, komplikado pa yung negative 1 times negative 1. Perhaps I can compute for it. Negative 1 times negative 1, right? So that means this is equal to what? Well, pwede nating i-browse. Ano nga ba yung mga arithmetic na alam na natin before? So let me just go up and shop for a theorem that I can use. Siguro babalik ako sa theorem 1.3. And here we go. I have additive inverse of A times additive inverse of B equals A times B. So look at theorem 1.3.6. Okay. Now I can use that here. So kapag ka pala may dalawang additive inverses akong, or meron akong dalawang additive inverse na pinagmumultiply, ang product nila ay yung product lang nung mga inverses nila. So basically using that, this will just be 1 times 1 by theorem 1.3.6, okay? And then 1 times 1 is equal to 1 by the property of multiplicative identity, by 1 being the multiplicative identity. Sana nababasa niyo yung sulat ko? Right. Okay. And so therefore, this means that since negative 1 times negative 1 is equal to 1, that means 1 is positive, which is a contradiction. Why do I say I have a contradiction here? Anyone aside from Neil or Dan?
Sir, because inassume po na element ng positive reals yung negative 1 sa una. So kung nag-contradict po dun sa result na 1 is an element of the positive reals.
Yeah, pero specifically ano na violate ko? You're on the right track. Hindi ba pwedeng yung 1 at saka negative 1 ay parehong positive?
Yun pong ano.
Hindi po pwede. Sa trichotomy action,
Sorry.
kahit isa lang po doon ang pwedeng tama.
Exactly. Yeah, perfect. That's correct. Dahil sa trichotomy action, di ba sabi natin sa action 10 ba yun? Ibig sabihin, exactly one of the following holds. A is 0, A is in P, or negative A is in P. Okay, we already discounted the fact that 1 is not equal to 0. And then we assume that negative 1 is already in P. So the other case, negative 1 being in P, should be impossible. Okay? So that means if we will accept the fact or our supposition that negative 1 is a positive number, then we will come up with another conclusion that 1 is a positive number, which violates an axiom. So, ibig sabihin may violation na doon. So, hindi pwedeng maging totoo ito. So, now we have proven, or so we need to reject the supposition. So, we conclude that 1 is actually a positive number. End of proof. So, ano nga yung tawag dito sa method of proof nito? It's reduction ad absurdum, reducing arguments to a contradiction. Or reducing a statement to something that is absurd. Okay? So from now on, pwede nyo tanggapin ng 1 ay positive number. Okay, and I guess that opens the floodgate in order to show or to characterize all positive numbers. Okay. Now the proof of the second half of statement 6 is similar. It's just that you want to show that negative 1 is less than 0. Pero actually, na-prove na rin natin yon, no? Kasi ang ibig sabihin ng 1, ng negative 1 being less than 0, this means 0 minus negative 1 is positive, right? But this guy would be 1 element of P, which we already have shown in our result earlier. Okay? So yeah, makakatulog na tayo ngayon ng maluwag because we have proven that 1 is a positive number. Okay? So I guess you can try. I hope you can try the other 6. Meron pa ba kayo nakikita ang posibleng maging mahirap dyan? I think the remaining statements could be proven in a similar fashion. Just go back to the definition of less than. Okay. So if there are no questions, then I can move on to the next statement. Oh, by the way, here, statement 2 sometimes is what authors refer to as the trichotomy axiom, which is perfectly fine. It's just a play on the definition or on the semantics. So when we say trichotomy axiom, either I am referring to A10 or to Theorem 1.5.6. Okay. Now another familiar term here, we define what an absolute value is. So if you have a real number A, it is its absolute value denoted by A imprisoned inside double bars. This is the number A if A is greater than or equal to 0, and it is equal to negative A if A is less than 0. Okay. And then Theorem 1.6 are 3 results that you had been familiar with since Math 17 or your ano na bang first math course nyo? Math 25 ba kayo or Math 17? Ang luma na nung Math 17. Dapat pala tigilan ko na yung pag-example ng Math 17. So here, the product of the absolute value of a product is the product of absolute values. The second one is what we call the triangle inequality. And we can try to generalize it later. And then the third Okay, sorry about that. I got disconnected. Yan, wala na nga ako. But hopefully I'm back now. Yeah. Kailangan ko talaga naka-on lahat ng internet sources ko. My home Wi-Fi got disconnected. So I'm now using my mobile data. So hopefully hindi na ako maputol. Pero hopefully nandito na ako. Can you confirm na nakabalik na ako sa meeting?
Yes po, sir.
Okay, hold on. Kailangan ko naman ay yung iPad ko. Hold on. So, yeah. Kita nyo, hindi lang estudyante ang nahihirapan sa internet connection, pati instructors din. Okay, so let me restart my sharing. Okay. So everything's good so far? Aside from my crappy internet connection. Okay, sorry about that. Lalo na sa mga naka-headset. Don't know what happened, but yeah. Okay, I was saying that the proof of the theorem involving the three statements involving the absolute values should come naturally, and they will just require the use of the definition of the absolute value and the definition of the less than relation. Okay. So you can try them on your own. And now let's move on and see how we define intervals in the set of real numbers. So for this course, we will adopt the usual interval notation. So we'll use brackets to denote the inclusion of those boundary points. So when we say bracket AB, that's the closed interval AB. And it includes all real numbers between A and B included. And then we will use parentheses to denote that we are including in the set all numbers between A and B, but the endpoints A and B are not included. Then we also have half open and half closed interval. All right. So tulad nito. And then for infinities, whenever you have an infinity as a boundary, we always use parentheses. I don't know if later I need to introduce a notation where I include a bracket there, probably sa 156 pa or sa 230 if you'll be going to graduate studies. But for now, let's stick to putting parentheses for infinities, either positive or negative infinity, to denote that hindi naman talaga real number yung plus or minus infinity. So hindi sila pwedeng makasama dun sa set. Okay? All right, so one result that we might need later for succeeding statements, or the proof of succeeding statements, is lemma 1.1. It says that here, if you have two real numbers A and B, then if A is less than or equal to B plus epsilon, for all epsilon greater than 0, then A is less than or equal to B. Okay, so basically this statement says na kapag si A ay mas maliit kaysa kay B plus epsilon, sa kahit ano pang epsilon, then ang A ay less than or equal din kay B. Well, in mathematics, we usually use epsilon to denote a very small number. Okay? So pag nakakita kayo ng epsilon, pwedeng imagine isang napakaliit na number. So ibig sabihin, kapag ka daw si A ay mas maliit or equal to B plus a very small number, then it automatically follows that A is less than or equal to B. Okay? So this could be one result that we will use later. Okay. Now let's see the proof of that. Okay, I think that's included here. And the proof again is by contradiction. So let's see why. So here we will assume that the statement to be proven is false. So that means we want to show, remember, that A is less than or equal to B. Then we'll suppose the negation of that. So ang negation ng A less than or equal to B ay A greater than B. Okay? And then the statement is claiming na ito yung premise natin. Remember, A is less than or equal to B plus epsilon for all epsilon greater than 0. So dahil yung statement ay totoo daw, para sa lahat ng epsilon greater than 0, I can cook up an appropriate value for epsilon. Pwede kong pumili ng kahit anong epsilon na gusto ko. Alright? So in this case, I am choosing epsilon to be equal to a minus b over 2. And I know that this is positive because by our supposition, a is greater than b. So mas malaki si a kaysa kay b, so yung a minus b ay positive, divided by 2, we'll get a positive number back. Right? So that qualifies as a choice for epsilon. But what's the beauty of choosing that specific epsilon? Well, we are assuming that this is true, right? Part of the premise. So ibig sabihin daw si a ay less than or equal to b plus any epsilon of our choosing. But again, we elected to choose a minus b over 2 to be our epsilon. So magkakaroon ka nito. And then if we add these two guys together, we're going to get a plus b over 2. Okay? But what is a plus b over 2? Well, note that a is larger than b. Okay? So that means this guy is smaller than a plus a over 2. Tama? Kasi by our supposition, si a ay mas malaki kay b, ay strictly mas malaki kay b. So therefore, papalitan ko lang si b ng isang number na mas malaki sa kanya, say a in particular, then I'll get a larger number. Okay? But this guy is equal to 2a, which is equal to a. So ibig sabihin, si a ay less than sa sarili niya, which is a contradiction. All right? So that means we need to accept the negation of our illusion. Okay. So therefore, that means that this supposition is false. Therefore, we must accept that a is less than or equal to b. Okay. So this is a useful lemma. So it's labeled as a lemma because lemmas are statements that are valuable for the sake of what is to follow, or they are valuable as tools for other proofs. Okay. So remember that lemma. And now let's go to ordered fields. All right, so here we define an ordered field. So if you have a set S together with two arbitrary operations, say plus and times, then, and also a subset P of S, then if this structure, the set S, yung dalawang operations, at saka yung set P, the subset ni S, ay nasatisfy yung corresponding versions of axioms 1 to 11, then that's what we call an ordered field. Yung axioms A1 hanggang A9, sila yung field axioms, which probably you will encounter also in Math 111 to be the field axioms, while yung 10 and 11 are exactly the order axioms. Okay. So since we know that those statements are assumed to be true for the set of real numbers, then we say that the set of real numbers is an ordered field. And there could be some other sets that are ordered fields. Kailangan lang nilang masatisfy yung corresponding versions ng 11 axioms that we have presented so far. So for instance, in the first example, ay isa ring ordered field. Because if you will replace all mention of the set of all real numbers in axioms 1 to 11, you will see that the set of rationals will satisfy all those axioms. So therefore, Q is also an ordered field. Okay. Now, finite fields ay hindi ordered fields. Probably it's nice to think of ano yung nababiolate nila dun sa 11 axioms na yun. Kasi pag meron kang finite field, hindi sila pwede maging isang ordered field. Okay. And then also in your homework, in homework 1, you need to argue or to reason out that the set of complex numbers is not an ordered field. So ano kaya dun sa 11 axioms ang hindi niya na-satisfy? You don't need to write a formal proof, just mention ano yung hindi niya na-satisfy at bakit. kahit intuitive lang. Ikwento nyo lang sa akin in 2 or 3 sentences why the set of complex numbers is not an ordered field. Basically, dapat may na-violate siya from axiom 1 to axiom 11. Kailangan nyo lang sabihin alin doon specifically and why. Okay? But again, no formal proof required. Kwento nyo lang sa akin. Okay. Another example is the set of all algebraic numbers, the real algebraic numbers. So we say that a real number is algebraic if and only if it is a solution to a polynomial equation with integer coefficients. So, meron kang real number, tapos makakahanap ka ng polynomial ng coefficients ay integers. Kung saan siya ay root nun, then that number is algebraic. Obviously, lahat ng rational numbers ay algebraic because any rational number m over n is a solution of the linear equation m minus nx equals 0, right? Because if you will solve for this, you'll get x equals m over n. Also, square root of 2 is an algebraic number because siya naman ay solution nitong equation na to. 2 minus x squared is equal to 0. So, mas malaki yung set of all algebraic numbers kesa sa set of rational numbers because all rational numbers are algebraic numbers. And actually, even more than that, there are some irrational numbers that are algebraic, like square root of 2, right? Pero may example pa. Pero hindi niya kayang kunin lahat ng real numbers. Not all real numbers are algebraic. An example of a real number that is not algebraic is the natural logarithmic base e. Hindi siya algebraic kasi hindi ka makakapag-design ng polynomial with integer coefficients na siya yung root. Ng root ay e. Okay? Oh, by the way, nakikita niyo ba yung annotations dun sa screen ko?
Yes po.
Okay, thank you. Kasi hindi ko na siya nakikita sa laptop ko. So, okay. So, yeah. Now we go on to completeness actions. Parang dami na nating nagagawa, no? Napagod na rin ako, pero we still have, how many? 28 minutes left. So we can finish completeness action. So the completeness axiom is another axiom which will distinguish it from all other ordered fields. Kasi marami pang ordered fields. CQA ordered field, who else? The set of all algebraic real numbers is also an ordered field. Pero what distinguishes, or what's the nice thing about the set of all real numbers that sets it apart from all other ordered field? And that's the notion of completeness. Now, maraming version ng completeness axiom. So for this particular case, or for today, I'll present 2 of them, okay? But we have said we need to choose which one to treat as an axiom, okay? So the first is, I think this is the most abstract version of the completeness axiom. This is called the Dedekind completeness axiom. So, and then it's labeled as axiom 12. And what is this about? So axiom 12, we suppose A and B are 2 non-empty set of real numbers satisfying properties 1 and 2. What are these 2 properties? Well, if A is in A and B is in B, then A must be less than or is less than B. So ibig sabihin lahat ng members ni A ay mas maliit sa lahat ng members ni B. And then the second property is that every number should either be in A or in B. Or in other words, A and B are A and B partitions the set of all real numbers. So if we take the union of A and B, we should get the set of all real numbers. So basically, kung meron kang dalawang sets, A and B, that satisfies properties 1 and 2, then surely, by this action, we are sure that the following 2 things happen. There is Okay, sorry, nawala na naman yata ako. Hopefully, I'm back. Ano nangyayari? Dalawa na yung... Okay, hopefully I'm back again. Dalawa na yung connections kong ginagamit pero nagfa-fail pa rin. Do you see my screen? Am I back? Or hindi pa rin?
Okay.
Okay, yeah, it's a thumbs up. Thank you. All right, so I'm back. So yeah, yung completeness action tells us na kapag ka meron kang dalawang sets of real numbers, such that if A is in A and B is in A, then A is less than B. And then if A and B partitions the set of all real numbers, then there should exist a real number C. Actually, not just the existence of a real number C, but there should be a unique real number C satisfying two things. Number one, if A is less than C, then A is in A, and if B is greater than C, then B must be in B. So graphically, perhaps it's easier to to understand the Dedekind's completeness axiom if we will draw a diagram for this. Okay, so in diagram or geometrically, so kailangan daw meron tayong set A at saka set B satisfying conditions 1 and 2. So kung ito yung real number line, okay, so ito yung real number line, okay, and then kunin kong set A ay ito, tapos ito yung kunin kong set B, okay. So perhaps kulayan ko siya ng so yung blue line that represents the set A, and then yung orange line. Yes.
Ako lang po ba yan or hindi ko po nakikita
Wala ba?
yung ginagawa nyo po? Kasi yung module po yung nasa screen.
Yung sa akin nawala din po.
Try ko lang i-reconnect ulit. Okay, so let me try this one. Okay lang, palit na ako ng network. Pero nakikita nyo ba? Kita nyo na ba yung annotation? Nagdododal ako ng kung ano-ano.
Yes po.
Kita na po, sir.
Okay, thank you. Sorry about that. Though hindi ko pa rin siya nakikita sa laptop ko. But now, okay, let me start from the beginning again. So ideally, ito yung sinasabi ng Dedekind's completeness, right? So meron kang set of all real numbers. So I will use it, I will denote it using the real number line. And then meron daw akong set A and B. Na kapag ka si A ay na kay A, tapos si little b ay na kay b, then dapat si A mas maliit kay B. So and then also, I should partition the set of all real numbers into the two sets A and B. So I guess there's no other option but to choose the sets A and B this way. So pwedeng si set A ko ay ito. So ito yung set A. And then set B would be this set. Okay? And let's see. So kapag kada kumuha ko ng isang element ni A, tapos kumuha ko ng isang element ni B, dapat daw yung element ni B ay mas maliit kay A. And imagine doing it for any element of A and element of B, then we're still good, right? Na-satisfy ko yung condition 1. And then condition 2 actually is easier to see. If I get the union of A and B, then I should get the set of all real numbers. Obviously, this union with this will give me the real number line, okay? So I have satisfied conditions 1 and 2, and I guess this is the only way we can satisfy condition number 2, okay? Now, the completeness axiom guarantees that we can find a real number C such that whenever a number A is less than C, then that number belongs to A. And if another number is greater than C, then that other number belongs to the set capital B, okay? So basically, what do you think is the candidate here for the unique number C? So actually, ang candidate para kay C ay itong number na to. Okay. And Dedekind's completeness axiom tells us na, yeah, laging merong C at yung C na yon ay unique. All right. And this is a completeness axiom because we accept this to be a fact for the set of all real numbers. So siya yung tinatawag nating Dedekind's completeness axiom. And the sets A and B are usually called Dedekind's cuts. Okay. Or actually, yeah, they are also called the Dedekind's rays. So merong ray 1, ray of type 1, or ray of type 2. But essentially, that's the idea of Dedekind's completeness. Okay. So kapag ka meron kang dalawang sets, A and B, satisfying properties 1 and 2, then you can always find a unique number C such that conditions A and B are satisfied. Okay. Now, in this particular case, any Dedekind cut will either be a half or half lines. They would be half lines, either having an endpoint C included or the endpoint C not included. Okay. Now, remark 1.7 tells us that this axiom does not hold for the ordered field Q. And this is what we promised, that this completeness axiom will set the set of real numbers apart from all other ordered fields, all right? So remember that the set of rational numbers is an ordered field, but we say it is not complete, or it will not satisfy Dedekind's axiom. Okay, why? So let's consider this sets A and B. So, but basically, papalitan ko lang yung lahat ng set of all real numbers sa Dedekind's completeness axiom by Q. So, halimbawa, ito ay rational, okay? Then there should be a rational number. So, ganito nyo tinetest kung mag-hold siya sa ibang ordered fields. Palitan nyo lahat ng mention ng real numbers by the specific number set that you are considering. So in our case, we want to prove that the set of all rational numbers doesn't satisfy Dedekind's completeness. So kailangan kong palitan lahat ng mention ng real numbers by the rationals. Okay? So I will consider these two cuts of rational numbers. The set A is the set of all rational numbers that are less than square root of 2. And set B is the set of all real numbers, the set of all rational numbers greater than or equal to root 2. Okay, let's check. Is condition number 1 satisfied? If I get an element of A, will that always be less than the element of B or any element of B? Yes, by definition, right? Lahat ng element ni A mas maliit sa kahit na nung element ni B. Condition 1 satisfied. Condition 2 is that if I take the union of A and B, will I get the set of rationals back? And that's also satisfied. Kasi less than lahat ng mas maliit kay root 2, lahat ng mas malaki kay root 2, then I get back the set of all rational numbers. So no problem with conditions 1 and 2. Now the kicker is, okay, if we will accept Dedekind's completeness to hold, then dapat ay may makuha tayong rational number C that satisfies this condition. Okay? So kung ino-drawing ko yung set of all rational numbers, susulat ko siya dito. Okay. Ito ay Q. So sulat ko siya dyan. Tapos halimbawa nandito si root 2. Okay? Tapos ito si cut A. Tapos ito si cut B. Okay? But I know that square root of 2 cannot be in the set of all rational numbers because we have proven last time that root 2 is irrational. Okay? So, ang guarantee ng Dedekind's completeness ay, kung complete talaga yung inyong ordered field, dapat may what's our only candidate? Ano lang yung pwede kong candidate para sa number C? Anyone? Sa cuts A and B para sa rational numbers, what's my candidate for that number C? Na kapag yung rational ko ay mas maliit dun sa number na yon, then element siya ni A. At pag meron akong rational number na mas malaki sa number na yon, then meron akong, then that number is an element of B. Anyone? Any idea? Actually, for this particular case, there's only one candidate, and that candidate is root 2. Okay? So, ibig sabihin, si root 2 lang yung pwede kong maging value ni C. But unfortunately, C is not a rational number, right? We have proven before that C is irrational. So therefore, it cannot be the unique rational number guaranteed, or that should be guaranteed by Dedekind's completeness axiom. Pero si root 2 ay hindi rational. Siya lang yung candidate, so therefore there is no such rational number. And so, hindi na satisfy yung completeness axiom. Okay? So this shows that the set, the ordered field Q is not complete. Ibig sabihin may butas dun sa set of all rational numbers. Hindi pa siya kumpleto. That's why we call it completeness. Unlike the set of rational numbers na walang butas. So kung i-drawing niyo yung rationals, posibleng mas tamang drawing ng rational numbers ay ganito. Dikit-dikit sila pero there is still some spaces between two rational numbers kasi hindi nga siya complete. But if you will draw the set of real numbers, then it is a straight line without any holes in it. Okay? All right, so napaka-technical ng Dedekind's completeness axiom. So probably in graduate courses, this is their version of the completeness axiom, but there is an alternative to it. We can derive some other statements that are equivalent logically to the Dedekind completeness axiom. Actually, hindi lang isa. There are at least 7 or 8 of them na equivalent sa Dedekind's completeness. But again, by our rule of a mathematical discourse, we want our axioms to be independent, meaning no axiom must be derivable or provable from the other axioms. So kailangan pumili lang tayo ano yung ating magiging axiom. So one possible choice is the least upper bound completeness axiom. So it says here that, or actually, didefine ko muna ano yung ibig sabihin ng upper bound and least upper bound. So definition 1.5, it states that A is an upper bound for a set S, even only if X is less than or equal to A for all X in S. Actually, ibig sabihin niya lang kapag upper bound siya kapag siya ay mas malaki or equal to everything in the set S. So A is greater than or equal to everything in the set S. Say that B is a least upper bound if it is the smallest among the upper bounds. So kung siya ay upper bound in the first place, and it is it is the smallest such upper bound. Kaya ang tawag sa kanya ay least upper bound. And we give the least upper bound a special name. It is called the supremum of the set, okay? Denoted by sup S. So, ibig sabihin, ang supremum, siya lang yung pinakamaliit na upper bound ng isang set S. And then we can define the infimum, which is basically the greatest lower bound in the same manner by replacing all the less thans by greater thans, okay? So, ibig sabihin, siya ay lower bound kung mas maliit siya sa lahat ng element ng set. Siya yung infimum kung siya ang pinakamalaking lower bound. Okay? So, totally nag-freeze na yung laptop screen ko. I hope I'm still here. Can you give me a sign na nandito pa ako? Or nawala na ba ako? Anybody? Just a sign. Galaw niyo yung baso.
Sir, nandito ka pa
Nandiyan
po.
po.
Okay, thank you. Yeah. Na-bother na ako kasi wala akong nakikita sa screen ko. But anyway, thanks. I'm still here. So let's see. Definition 1.6. A set S is bounded above if it has an upper bound, and it is bounded below if it has a lower bound. And actually, we can add one thing to this. We can say that a set is bounded if it is both bounded above and bounded below. Okay. Then we have remark 1.8. If a set has one upper bound, then it has infinitely upper bounds. Kasi pag meron kang isang upper bound, lahat ng mas malaki sa upper bound na yon ay upper bounds din. By Dedekind's completeness, right? So marami pa tayong makikita na mas malaki dun sa set na yon kasi pwede kong piliin yung Dedekind cuts A and B such that that one upper bound that we know actually will be the number C. So kaya infinitely many pa rin yung upper bounds if you find one upper bound. And then if the supremum or the infimum exists, then it should be unique. Hindi pwedeng magkaroon ng dalawang suprema o dalawang infima para sa parehong set. Because here, if B1 and B2 are both suprema, okay, ibig sabihin, pareha silang least upper bound. So, ibig sabihin, yung B1 ay less than or equal to B2 kasi pareha silang upper bounds. Si B1 daw ang least upper bound. So, dapat si B1 is less than or equal to B2. But if you reverse the roles and we accept the fact that they are both suprema, then B2 must also be less than or equal to B1. And this compound proposition here means that B1 must be equal to B2. So therefore, the supremum, should it exist, is unique. Okay. And then incidental to the next portion of the remark is that the supremum is not necessarily a member of the set. Okay. Pero kailan siya nagiging member ng set? Nagiging member siya ng set kapag may maximum yung set. So if there is a maximum, when we say maximum of a set A, siya ay yung maximum na yon ay element ng set at siya yung pinakamalaki dun sa set na yon. And if a set has a maximum, then that maximum will also be the supremum. Okay? Kasi yung supremum hindi kailangan nandun sa loob ng set. Pero yung maximum dapat nandun sa loob ng set. Okay? Now for instance, the closed interval 0, 1, the supremum is equal to 1. Sorry, hindi ko na-press yung mute button. But essentially, okay, so you can prove it two ways. I think method 2 is easier. So here we just use the fact that the maximum number on the closed interval 0, 1 is 1. So by remark 1.8c, actually this should be C. C1 yung supremum. And then there's a longer proof. I'll just assign this as a reading assignment. Read method 1 of the proof. Okay. Para mapakita ng supremum ng closed interval 0, 1 ay equal kay 1. I need to assign that to you so that I can go to the least upper bound completeness axiom. Now the LUB axiom tells us na if you have a non-empty set of real numbers, which is bounded above, then that set S must have a least upper bound in R. So in a nutshell, the LUB property tells us that every non-empty set of real numbers that is bounded above should have a supremum. Okay? And that supremum must be in the set. So yun yung mabigat sa LUB. Kung meron siyang, actually hindi pala kailangan nasa loob ng set. So basta meron siyang supremum. Okay? So any non-empty set that has an upper bound must have a supremum. Okay? So just some few remarks. The Dedekind's completeness axiom and the LUB completeness axiom are equivalent to each other. So you can prove one coming from the other. And so we can interchange these two as our completeness axiom. Pwede tayong mamili alin sa kanilang dalawa ang gagawin nating completeness axiom. And usually, we will use the LUB axiom as our completeness axiom rather than the very abstract Dedekind's completeness axiom. But again, the two are logically equivalent. So it doesn't matter which one we put, but we cannot put both of them because one is provable from the other. Actually, there are some other equivalent forms for completeness. Meron tayong Cauchy's convergence criterion, nested interval theorem, the monotone convergence theorem, the Bolzano-Weierstrass theorem, the intermediate value theorem, finite covering theorem, and some more results. So now we will be electing the LUB property as our completeness axiom. So we might encounter these theorems later, pero sila yung mga theorems na lamang. Kasi i-assume ko na totoo yung, assume ko as an axiom yung LUB property. Okay? All right, so let's go to corollary 1.1. Suppose S is a non-empty set of real numbers, and we want to prove that it is bounded below. We assume that it is bounded below. Then we want to show that S has the greatest lower bound in the set of all real numbers. Okay, probably we can prove this on a separate page. Dagdag lang ako ng page. Okay. And this is what we want to prove. Okay. So ito yung corollary na gusto nating i-prove. Pero ang gagamitin natin ay yung LUB property. So basically, it's a corollary to the LUB property. So the main gist of the proof will revolve around the least upper bound principle. Okay. So let's start with let's start the proof. Okay. So our assumption is that S is a non-empty set of real numbers, and this set is bounded below. So meaning S is bounded below by assumption. So there should exist, say, a number little m, such that little m is less than or equal to S for all little s in the set S. Okay? So definition lang ng pagiging bounded below. Bounded below siya kung meron siyang lower bound. So, and then I specified m to be one of the lower bounds. Okay. And then this is equivalent to saying that negative m is greater than or equal to negative s for all s in capital S. Okay. So basically here, I'm saying that negative m is an upper bound for the set negative s, which is basically the set of all negative s's for all s in capital S. All right? Kasi kailangan ko siyang i-convert into a statement about upper bounds. Kasi ang meron tayong result ay least upper bound principle. Right? So everything good so far? Okay, I hope everything is well. Kahit I'm in the blind here, hindi na gumagana yung laptop ko. But anyway, I hope the arguments are clear. So see, negative m ay upper bound ni set negative s. Okay? Where I define the set negative s to be the set consisting of the negatives of all elements of the set S. Okay? Now, since negative m is an upper bound for negative s, then by the LUB principle, by the LUB axiom or principle, negative s has a supremum. Say, let's call it big M. So that is, big M is the supremum of negative s. Okay? So anong ibig sabihin ng pagiging supremum? So that means M is greater than or equal to negative s for all s in capital S. Kasi siya ay upper bound in the first place. So ibig sabihin mas malaki siya sa lahat ng members ni negative s. Okay, in capital ni set negative s. And si M, siya ang least upper bound. So pinakamaliit siya sa lahat ng negative M, where negative M is an upper bound for the set negative s. Okay? So yung pagiging least upper bound. Upper bound siya, so ibig sabihin mas malaki siya sa lahat ng elements ni negative s. Least upper bound siya, so mas maliit siya sa lahat ng upper bounds ni negative s. Okay? And so this means what? Well, these two things will imply the following. Negative m is less than or equal to s, right? From here, I multiply both sides by negative 1. I'll get this statement. And this is true for all s in S, meaning negative m is a lower bound for the set S. And actually, we have another thing. And we also know that negative m must be greater than or equal to m. So we got that there, right? So multiply ko lang both sides by negative 1. I get this statement. So this means that negative m is the largest among the lower bounds. Kasi si m ay lower bound ni capital S. So maybe I should write that down here for all lower bound m of S. Kasi dito alam natin na si negative m ay upper bound ni negative S. But we have proven earlier that if negative m is an upper bound for S, that is equivalent to saying that m is an upper bound for the set S. M is a lower bound for the set S. So kung si negative m ay upper bound para kay negative S, dapat si m ay lower bound para kay set S. Oh, let me repeat that. Kapag si negative m ay upper bound para kay set negative S, dapat si little m ay lower bound para kay set S. But here we said that m is less than or equal to negative m. On the flip side, we can show that negative m must be greater than or equal to m. But m is a lower bound of set S. So ibig sabihin si negative m ay isang lower bound at mas malaki siya sa lahat ng lower bound except possibly for itself. So therefore, the infimum of the set S is equal to negative m. Okay? But what is negative m? Negative m is actually the supremum of the set negative S. Okay? And that's the end of the proof. Because we have shown na kapag ka merong lower bound, meron din siyang infimum. And that essentially is guaranteed by the least upper bound property. Okay? Now, the last sentence here in my proof actually is the remark shown here. That is remark 1.10. Okay. Wala na naman yata yung share screen ko. Okay. Nag-freeze na siya ulit. terrible connection. Sorry about that, class. Mukhang blockbuster in terms of bandwidth. In terms of bandwidth used yung time slot natin. So hopefully it gets better in the next few days. But any questions? Oops, not YouTube. There you go. Balik ko lang siya. Mukhang nag-freeze na naman yung ano ko. Nag-freeze na naman yung share screen ko. But I think I will end here. Meron bang importanting point na naputol ako kanina dun sa proof?
Wala naman po, sir.
Okay, so that's good. And I think you have all the necessary tools for you to answer homework 1. So any questions? By the way, for those who downloaded homework 1 early, may binago ako, nagdagdag ako ng bonus question. So that's worth 1 point. So pwede nyo i-redownload yung homework 1. Or you can just add your answer to the bonus problem. The bonus problem is worth 1 point, but remember yung homeworks ay worth 5 points lang. So that means you can get as much as 6 over 5. So meron kayong 20% bonus. So I think that counts. That counts to your final grade. So don't forget to answer the bonus questions. Kasi baka ignore nyo siya kasi +1 lang naman. Pero +1 over 5, that's essentially 20% on top of your actual score. So yeah, makakatulong yun sa inyo. So answer the bonus problems in the homework, okay? So again, I apologize for the crappy internet connection I have today, but any other questions or parting thoughts? Wala naman. So thank you for those who participated today in by sharing their thoughts or their suggestions in the proof. Thank you all for coming today. Yeah, let's see each other again on Thursday to start actually kung ano yung nakalagay sa week 2 modules. All right. Okay, with that, goodbye guys. Have a good night.
Thank you
Thank
po,
you,
sir.
sir.
Thank you, sir.
So,